Hello students, very good afternoon. This is Mayur S. More, your chemistry tutor, as you all know. So I welcome you all to JEE Chemistry session number maybe third or fourth, I guess, you know. So yeah, so we started a chapter called ionic equilibrium, isn't it? Hello students, very good afternoon. This is Mayur S. More, your chemistry tutor. I welcome you all to JEE Chemistry session number maybe I guess fourth, yeah, fourth for ionic equilibrium. So we started this chapter couple of sessions ago. We already finished the chapter called chemical equilibrium. Then we came to chapter called ionic equilibrium. Okay, so now we have started it. We had seen how the dissociation of the ions affects. Okay, and today we're going to see the pH and pOH. Okay, the name of session, the name of today's session is pH and pOH. Okay, but before I could move to pH and pOH, let's see how the water affects it. What are some of the properties of water? Because properties of water are going to play a vital role in finding out the H plus ion concentration and OH minus ion concentration and thereof a pH and pOH. Okay, so yeah, so let's begin. I welcome you all to JEE Chemistry. Let's begin. Properties of water. So as we all know, we had seen the RNAs theory, Laurent-Mostert theory. Okay, there was one more theory which was led to see, that was Levi's acid-base theory. But anyways, we will discuss that in the upcoming session. For the time being, see, you know that water is an amphiprotic, right? Amphoteric, or I would say amphiprotic, as acid-base nature. That means what? With acid, your water can act as a base. With a base, your water can act as a acid. That is the property of a water. Okay, that's a unique property of your water. So, as far as that, no, as far as Laurie Bronsted is concerned, your water is an acid as well as base, right? So we had seen those theory, but there was one theory, that theory now called as Levi's concept. According to Levi's concept, any compound which has a lone pair will act as a base. Basically, lone pair donors are bases, lone pair acceptors are the acids. So, according to Levi's concept, your water can only be taken as a base. Water can only be taken as a base. Okay, now that is for, so these are the, what I would say, these are the conflicts. These are the conflicts between the theories to what to like how to classify your water, whether be it an acid, be it a base, whatever it is. Okay, but these theories had these conflicts. Okay, but in reality, your pure water is always found itself in a dissociated form as H plus and OH minus. So it is what? It is neutral. The pure water is neutral. Now, how can we find out the molar concentration or molarity of water? So as far as molarity of water is concerned, suppose if you have taken a 1 liter of water. Now 1 liter of water is how much? 1 liter of water is equal to 1000 ml. Okay. Now 1000 ml of water is also equal to 1000 grams. Isn't it? Why? It's because density of your water, density of your water is 1 gram per cubic centimeter. That is the density of your water. So that is why 1000 ml will be equal to 1000 grams. So now 1 liter of water has 1000 grams. Okay. And what is the molecular mass of water? Molecular mass of water is 18 grams, isn't it? It is equal to 18 grams. Okay. Then how do you find the molarity? Molarity is equal to number of grams, number of amount of water. How much amount of water we have taken? 1000 grams, isn't it? 1000 grams divided by, what is the molecular mass? 18 grams, right? So basically you are dividing 1000 by 18. What do we get? 18 5s are 90, right? You got 10, 0. Again, 18 5s are 90 point. You got 10 there, 0. 18 5s are 90. Again, you will be 10, 55.55. 55.55 moles per liter. That is the concentration of water. Now, it might sound something strange to hear, because you are finding out the concentration of water in water itself. But yes, even if it sounds strange, it is possible and it is a valid concept. The concentration of your water is 55.55 moles per liter. Okay, now let's come to the ionic product of. So this is what the concentration of water. Now this concentration of water might increase, might decrease, that we will see. But in other, generally it doesn't increases, doesn't decreases. We will, and even if it does, we will see that. Okay. Now the ionic product of water. Now what is ionic product of water? So according to Arrhenius concept, your water can dissociate as H plus and OH minus. So what is the ionic product? Basically, it is nothing but what? Do we have a space? Okay, I'll tell you here what is the ionic product. See, this is water. The water will dissociate like this, plus OH minus. Okay. So initially we don't know how much moles it has. Suppose it has one only. It is 0, 0. Now at equilibrium, this is your initial. At equilibrium, suppose this is somewhere like what? C alpha. This is also C alpha. This is 1 minus alpha. So basically Kw or ionic product of water is what? Concentration of H plus, concentration of OH minus. Now you would say, where did this H2O went? So basically, if I write it, firstly we need to write K equilibrium. So K equilibrium is equal to concentration of H plus and concentration of OH minus divided by concentration of your water. Now see, water doesn't dissociate to that much extent. Water doesn't dissociate to that much extent. That means some part of water, I would say very large part of water, still remains undissociated. So that you are sending on the left hand side. So K equilibrium into concentration of H2O, that is equal to concentration of H plus, concentration of OH. So this K equilibrium into H2, this is equal to what? This is equal to your Kw. So that is how Kw is equal to H plus and OH. Okay, so yeah, so that is what I was saying. The ionic product of water, Kw. Now it is experimentally found out. This AXP means what? AXP means it has been found experimentally. Okay, so ionic product of water, Kw, is equal to concentration of H plus multiplied by concentration of OH minus is equal to 10 raised to minus 14 at 25 degrees Celsius. That means it is temperature sensitive. If the temperature changes, this value of Kw would also change. Okay, now one more thing. See this dissociation that you saw, this dissociation of your water is what? It's endothermic. Dissociation of your water is endothermic. So, on increasing the temperature, K equilibrium will surely increase. Now, since your K equilibrium increases, the Kw will surely increase because your Kw equal to what? Kw is equal to K equilibrium multiplied by water. So basically, your Kw also increases with increasing temperature. That is what the all funda is all about. So that means at the higher temperature, you will find water to be more dissociated. And at the lower temperature, you will find water to be less dissociated. That is what it all about. This was all about auto ionization of water. And I guess we had seen it earlier also. Okay. So this is not something new which I'm telling you. It is just that it is endothermic process. And as we all know, all the endothermic processes, their rate increases with increasing temperature. So since this dissociation of water is endothermic, with increasing temperature, its dissociation also increases. Okay, so moving ahead. Now, now we come to the pH and pOH. Now to understand this pH, pOH, you firstly needed to understand how does this Kw of water is, because it is surely going to affect them. And we're gonna see it in the upcoming slides that how does it affect. Or let me tell you here also. Tell you here only. Yeah. So pH. So this was a term coined by, I would say this was a term developed by Sorensen. It was developed by Sorensen. It's the name of a scientist. Okay, Sorensen. So what did he say? Is that pH is equal to negative logarithm of H plus ion concentration. So whatever H plus ion concentration that you have, if you take the negative logarithm of that concentration, you will get a pH. So pH is equal to negative logarithm of H plus ion concentration. And as far as water is concerned, if you find out the Kw of your water is Kw is equal to concentration of H plus ion and concentration of OH minus. So concentration of H plus ion is 1 into 10 raised to minus 7. Similarly, as you know, whenever water dissociate, you get the equal number of H plus ion as you get the number of OH minus. तो अगर H plus ion का concentration 10 raised to minus 7 है, तो OH minus ion will also be 10 raised to minus 7, isn't it? So if you take the negative logarithm of this concentration, it will be plus 7. Similarly, negative log of this concentration, it will be again be. So it's like that. So pH is equal to 7 and pOH is also equal to 7. So this 7 plus 7 is equal to 14, and that is how your pH scale was actually designed. So pH scale, this is the value of your pH, 0 to what? 14. 0 to. So you might have learned about this. You might have learned about this pH scale, maybe your 8th standard, or maybe your 9th standard. Okay. Now, depending on different boards. Okay. So this is 0. So this is now 0, 1, 2, 3, 4, 5, 6, 7. Then you have 8, 9, 10, 11, 12, 13. Okay. Now you know that this side is what? 0 to 7. This side is acidic. And this side 7 to 14 is what? It's basic. Okay. So basically your pH, if it is between 0 to 7, as you can see here, when pH is equal to 7, obviously your pOH is also equal to 7 that time. Because you can see here, if you take the negative logarithm of this is equal to 7, negative logarithm of this is equal to 7. This Kw, if you take the negative logarithm of Kw, what do you get? You get pKw. So pKw is equal to 14. Or you can also call that as pH plus pOH is equal to 14. This is that, like, to make you understand, this is rather easier approach. pH plus pOH is equal to, okay. So when your pH is equal to 7, obviously your pOH is also equal to 7. Why? Because when pH is 7, how can you find out the pOH then? 14 minus 7. So that comes out to be 7 only, right? So when pH is 7, pOH is also equal to 7, and it's a neutral in that case. Okay. If your pH is less than 7, if it is less than 7, then obviously your pOH would be greater than 7. Then solution would be acidic, at 25 degrees Celsius. Similarly, if pH is greater than 7, then definitely pOH is less than 7. And in that case, solution would be basic. Okay. So these are the pretty much basic things about pH and pOH scale. Okay. Now one thing I wanted to tell you here, and that is really important, is the ionic product. The ionic product of your water is always constant. Whatever has been dissolved in water, no matter whatever you dissolve in water, the ionic product, what is ionic product? pKw. Basically, Kw is equal to 1 into 10 raised to minus 14. And that is called as ionic product of water. So I will write it here, Kw 1 into 10 raised to minus 14. So this thing is called as ionic product of water. As you already seen, this Kw is nothing but the product of H plus ion concentration and OH minus ion concentration. And H plus ion concentration is 10 raised to minus 7. OH minus ion concentration is also equal to that. So together they give you 10 raised to minus 14. And that is called as ionic product of water. Okay, now, so as I was saying, ionic product of water is always constant. Whatever has been dissolved in water, no matter whatever it is always going to be constant. Why? Because it's an equilibrium constant. Equilibrium, you do whatever you want. You do whatever you want. Equilibrium will always try to balance itself. For a short time, short time, there might be some kind of aberration into it. But after some time, it will automatically balance it. Okay, that is why we are calling it as constant. Remember, it's a constant. Okay, but its value will be dependent only and only on temperature. That means temperature change can surely affect the change in a value of equilibrium. So that is the most important thing that you need to understand, that temperature will surely affect the equilibrium constant. Other things will not affect it at all because it's a constant. Okay. Temperature has a very, actually, I would say, temperature has a very significant role, not only in the equilibrium constant, in increasing or in decreasing the rate of soap in the reaction. Temperature is the most basic fundamental of your chemical reaction. Okay. On that note, let's move ahead. Now that you have understood what is pH, what is pOH, okay, let's see some of the other facets of it. So, before again to see that, let's see what is the degree of dissociation of water. Now, what is degree of dissociation of water? It is just like you are dissociating water and finding out how much water has been dissociated. Now we know that whatever water you have taken, out of that, your H plus will be dissociated to give you 1 into 10 raised to minus 7 moles of H plus ion. Similarly, 1 into 10 raised to minus 7 moles of OH minus, right? So how many moles actually dissociated? If you want to find out the alpha, or I would say degree of dissociation of your alpha, what is it? It's a number of moles dissociated divided by total number of moles taken, isn't it? Now, since you have taken a 1 mole solution of water, the total number of moles taken are how many? 55.55. Remember, we found it out in the very first slide, right? So, number of moles dissociated how many? 10 raised to minus 7. Right? That is what it is all about. So, 10 raised to minus 7 divided by 55.55. You ultimately get 1.8 into 10 raised to minus 7%. That is the alpha. Now remember, this is a percentage. So it's a very small. Or you can write it like this. Your alpha is equal to 0.0000001234561 8. That is what your alpha is. So that, and this is nothing but equal to what? 1.8 into 10 raised to minus 7. And remember, that is also percentage. So this is divided by 100. So basically here your alpha becomes what? Alpha is 1.8 into 10 raised to minus 9. Because 10 raised to minus 7 and this is 100. This 100 is equal to 10 raised to plus 2. When it goes up, it becomes 10 raised to minus 2. So 10 raised to minus 2 plus 10 raised to minus 2, it becomes 10 raised to minus 9. And that is why percentage alpha is equal to this much. So you now must have understood that how much smaller it is. It's a very, 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 very small quantity. And that is why we call practically water as undissociated. Okay. So yeah, that is what the, I would say, a practical approach to degree of dissociation of water. If you want to find out the absolute dissociation constant of water, then you need to do what? Then you need to consider either Ka or Kb. Okay. So Ka or Kb, H plus OH minus divided by H2O. You take both the concentration 10 raised to minus 7, 10 raised to minus 7, 10 raised to minus 14 divided by this. So you get the pKa of your water is 15.74, which makes water very weak acid. It's an extremely weak acid. Very, very, very weak. Okay. So moving ahead with this now. Now we came to pH scale. So pH scale, I already told you what is mean by pH, right? pH is equal to negative logarithm of H plus ion concentration. Okay. Now you might see a little bit change. You might see a little bit change in the terminology of that H plus ion concentration. Okay. But I will tell you what is it. So firstly understood that what is mean by acidity. See, acidic strength. Acidic strength means what? It is the tendency. It is the tendency of an acid to give H3O plus or H plus ion in water. Now we have discussed about it earlier also. Acidity means what? Any substance, any substance which increases the H3O plus ion concentration. Any substance which increases the H3O plus ion concentration in water is called as acid. Okay. So acidic strength means what? The tendency of an acid to give H3O plus or H plus ions in water. So greater the tendency, greater the tendency to give H plus ion, more will be the acidic strength of the substance. Now that's obvious, right? Tendency to give away H plus ion concentration is called as acidic strength. So more easily does it give H plus ion concentration, more will be its acidic strength. Okay. Similarly, what about base? Now basic strength. Just as pH, you can also find out the pOH. Now pOH is equal to what? It's a negative logarithm of OH minus ion concentration. Now see, generally you don't need to find out the pOH if you have already got the pH, because pH plus pOH is equal to 14, right? So if you know the pH, you can find out the pOH. Similarly, if you know the pOH, you can find out the pH. Okay. But sometimes there might be a cases where you need to find them out individually. In that case, this is the formula that you can use. pOH is equal to negative logarithm of OH minus ion concentration. pH is equal to negative logarithm of H plus ion concentration. Okay. So yeah. So then the basic strength. Basic strength means what? It is the tendency of a base to give hydroxyl ions. Basic strength means the tendency of a base to give the hydroxyl ion in a water. So greater the tendency to give OH minus ions, more will be the basic strength of the substance, isn't it? More easily does it use OH minus ion, more will be its basic strength, isn't it? Now the concentration of your H plus ion is written in a simplified form, as I told you, introduced by Sorensen, known as pH scale. What is pH scale? Now pH is defined as negative logarithm of activity of H plus ion. Now you might say, sir, what is this activity term suddenly came out? Activity of H plus ion is nothing but what? It's nothing but the concentration of H plus ion. Today, in today's world or in today's science fraternity, we called it as concentration of H plus ion. Okay, but earlier it was called as what? Activity. So don't get confused. This negative logarithm of activity of H plus ion is nothing but the negative logarithm of H plus ion concentration only. Okay, it is just that only the way which people used to call it have changed. Okay, so yeah, so that is what the pH is all about. Okay, now let's see some of the other facets of it. So yeah, so as I told you, activity of H plus ion is the concentration of free H plus ion. As I told you already, activity of H plus ion is nothing but the concentration of free H plus ion or H3O plus ions in a solution. H3O plus means what? You know that I have told you already in maybe first lecture. H3O plus ion nothing but equal to H plus H2O. Because your H plus ion doesn't exist as such. It exists in the form of what? It exists in the form of H3O plus. Okay. So yeah. Now again, here we are talking about pH scale, which I have already told you, right? The pH scale was marked from 0 to 14, where Celtran 0.7 to 25. Okay, taking water as a solvent. So the temperature of the solvent are changed, the pH range of the scale will also change. Okay, that will surely will happen. But generally your pH scale is between 0 to 14. Central point will be at 7 and two corners 0 and 14 will be like that, but that will be at 25 degree Celsius. Okay, that is when the water dissociates to give you 1 into 10 raised to minus 14. Remember that? And then we took a negative logarithm of that, which eventually gave us the KW14, PKW14, sorry. But all of that was happening at 25 degrees Celsius. That is why the pH scale that we know is applicable only at 25 degrees Celsius. But if the temperature is changing, and obviously solvent, that means if you change the solvent from water to any other solvent, then obviously this pH range scale will surely change, isn't it? But as far as temperature is changed, let's see. At 25 degrees Celsius, as I told you, it is 0 to 14. Okay. At the middle point, which is 7 point will be neutral point. Okay. But if you increase the temperature from 25 degrees Celsius to 80 degrees Celsius, as I told you, when you increase the temperature, the ionization or a dissociation of water will happen to more extent. Why? Because it was an endothermic process. So now your water has dissociated to the more extent. And now your pH scale has changed from 0 to 13. Now your neutral point will be 13 divided by 2. 13 divided by 2 is how much? 6 point. Okay. So that is how, if you increase the temperature further, remember, if you increase the temperature further, maybe 120, 30, 200 degrees Celsius, water will be found in a more dissociated format. And then pH scale could further come down. It might come to 12, 10, 11 like that. Okay. Now that will not happen actually. Why? Can anyone tell me in the comment section why that will not happen? It's because beyond 100 there won't be a water. The water will be vaporized beyond 100. Okay. Isn't it? The water will be vaporized. But if, if I consider a fictional case or a hypothetical case that if your water does not vaporize, if it stays as a liquid form only beyond 100 degrees Celsius also, then one thing will happen, that's for sure, and that thing will be there will be more dissociation. When there will be more dissociation, pH scale will further come down. It will be narrowing from 14 to 13 now at 80. It might come down to 12 or 11, something like that. then your neutral point will be whatever pH range you have, that divided by 2. Just like we have finding it out here. Okay. So I hope you must have understood what I'm trying to convey here. Okay. One more thing. Your pH can also be negative. Remember this point. Your pH can be -3, -2, -1 also. And it can also be greater than 14. It can also be 15, 16, 17, like that. So don't just get into the mindset that pH would exist only in that much range. We have kept it in that much range because that is convenient for us. And most of the chemical that we use in laboratory, as far as 10 to 12 standards are concerned, all those substances have the pH range in that range only. Okay. But at the advanced level, pH might be negative, it might be extremely positive. Okay. Chalo, moving ahead with this now. Now that you understood how dissociation of water is affected by different factors, and how does that affect the concentration of H plus ion, OH minus, which ultimately affects the pH and pOH. Now let's see how the different types of calculation of pH are there. pH calculation, okay, pH calculation of different types of solution. Let's see that thing now. Okay. Firstly, strong acid solution. What will happen? I mean, how do you find out the pH for a very strong acid solution? Okay. Now, see, whatever acid you have taken, maybe HCl, maybe HNO3, maybe H2SO4, whatever it is, it must have some concentration. And you might know the H plus ion, which comes from water, or OH minus ion, which also comes from water, has concentration roughly equal to 10 raised to minus 7. Okay. So whatever concentration you will have for your acid, it will surely be higher than this. That is the point I'm mentioning here. If the concentration of what? Concentration of your acid. If the concentration is greater than 10 raised to minus 6 molar, if the concentration is greater than 10 raised to minus 6 molar, in this case, H plus ions coming from water can be neglected. That means whatever H plus ion concentration, let me point it out here. H plus acid means what? The H plus ion coming from acid now. H plus ion coming from acid, if its concentration is higher than 10 raised to minus 6, if its concentration is higher than 10 raised to minus 6, then the H plus ion coming from water can be neglected. Okay. So in that case, the concentration of H plus ion is nothing but the normality of strong acid solution. Okay. Yeah. Now, that is the thing. Now remember this always in a calculation. You need to remember this thing always. That is why I'm putting a star here. Remember this. But what if the concentration is less than 10 raised to minus 6 mole? Sometimes it might happen that the concentration of H plus ion given by your acid, it might be less than your 10 raised to minus 6. It might be less than your 10 raised to minus 6. Then what do? Then you need to consider the H plus ion which came from the water. Okay, because now that will affect, or I would say, that will add the H plus ion concentration to the H plus ion concentration of acid substantially. Now that will increase the concentration of H plus ion, and therefore now that will surely have the impact of either increasing or either decreasing the acidity. Okay. So let's understand the reason behind that also. So this reason I already told you. Whenever this H% concentration is greater than 10 raised to minus 6, that means it is the order of 10 already. So even if you add 0.1 into 10, what do you get? 10.1 only, right? So if you take the log of 10, log of 10 is 1 only. Similarly, if you take the log of 10.1, would it be something very different? No. It will be something like 1.02 or 1.03, something like that. So it will be around that range also. So it will be around that range only, and that is why whenever if your H plus ion concentration came from the acid, if it is larger than 10 raised to minus 6, you can straightforward neglect the concentration which came from the water. Okay, but if it is less than 10 raised to minus 6, then surely you need to consider the H plus ion concentration which came from the water, because now the the water will have more acidity than the compound that you added actually. Okay, we will understand that through an example in a better way. Okay, so point I was making here is that if concentration is less than 10 raised to minus 6 molar, in this case H plus ion coming from water can't be neglected, and in this case H plus ion concentration will be equal to normality of your strong acid plus H plus ions coming from water in presence of strong acid. Okay, here it might look very much textish, or I would say theoreticalish. Okay, but you will understand this in a better way when I take an example on that, basically numerical. Okay, so moving ahead now, look at this numerical now. Calculate the pH of 10 raised to minus 8 molar of HCl. Now 10 raised to minus 8 molar of HCl, that means what? Suppose if I consider HCl to be strong acid. Now HCl is an strong acid, okay, but it's not that strong acid. If you compare it with the leagues of HNO, if you compare it with the leagues of H2SO4, HClO4, those are, or HI, those are very strong acid. Okay, but for the time being, let's suppose HCl is a strong acid and it dissociates completely. So if it dissociates completely, it will produce the H plus ion equal to 10 raised to minus 8 molar only. Because the concentration, because the concentration of your acid is how much? Concentration of your acid is 10 raised to minus 8 molar, isn't it? So H plus ion concentration would also be equal to 10 raised to minus 8. Now this 10 raised to minus 8 is surely less than 10 raised to minus 6 molar, isn't it? Right? As I told you in the previous slide. So this 10 raised to minus 8 is less than 10 raised to minus 6, right? So then what do? You can't neglect, you can't neglect the H plus ion concentration which came from the water. You simply can't ignore it. So then we write it. How do we write the dissociation? HCl plus H2O. What does it give you? H3O 1 plus Cl minus. Okay. Now the initial concentration of HCl is given 10 raised to minus 8. We don't consider the water H plus ion concentration or any concentration of water, we don't know. So let's suppose it is X. Okay. 10 raised to minus 8 plus X. Okay. And here it's X, right? We already know that is what we do, right? We take the concentration of HCl 10 raised to minus 8. H3O plus is what? 10 raised to minus 8 plus X means what? It actually came from the water. It's a water's concentration, right? That will get added, no? Or let me write it once again so that you will understand in a better way now. Okay, HCl is a 10 raised to minus 8 molar initially. Okay. And suppose water is what? Let's suppose it's a 1 molar. Okay. H3O plus is what? It's a 10 raised to minus 8. Initially, okay, water hasn't dissociated just as yet. Similarly, this also 10 raised to, no, let's consider this X only. Okay. So now at equilibrium, what will happen? Your HCl is 10 raised to minus 8 molar only. This is 10 raised to minus 8 plus X, right? 10 raised to minus 8 plus X. This is also X. Now what do? You write your Kw, right? Kw is equal to concentration of this, concentration of that, 10 raised to minus 8 plus X into X divided by 10 raised to minus 8. How much is your Kw? Let's go to the next page. Kw is 10 raised to minus 14, isn't it? 10 raised to minus 14. This Kw 10 raised to minus 14. Now 10 raised to minus, okay, we got what? 10 raised to minus 8 plus X into X divided by 10 raised to minus 8. Okay. Now you will send it to that side. 10 raised to minus 8 will become 10 raised to plus 8. So you will get 10 raised to minus 6 to that side. 10 raised to minus 6 is equal to 10 raised to minus 8 x plus x square. Isn't it? You multiply this x now. So what do you get now? X square plus 10 raised to minus 8. Oh, what I'm doing here? Just a sec, okay? This might take some time, okay, for calculation. X square plus 10 raised to minus 8 x minus 10 raised to minus 6. Okay, that is equal to 0. Now this equation comes into the form of ax square plus bx minus c is equal to 0, right? Now we need to find out the x, right? Because once you get the x, you will get the H plus ion concentration. And then you can find out the pH, isn't it? So yeah. How can we find out the root x here? Your x is equal to minus b plus minus b square minus 4ac upon 2a, right? Minus b, no? So 10 raised to, this is your b, 10 raised to minus 8. So minus 10 raised to minus 8, right? Plus minus b square, which is 10 raised to minus 8 square. B square minus 4. AC. A is what? 1. C is what? 10 raised to minus 6. Isn't it? So that divide by 2. Right? Now what do we get here? Minus 10 raised to minus 8 plus minus under root 10 raised to minus 16 minus 4 into 10 raised to minus 6 divided by 2. Okay. So yeah. So what do we get now? Your x is equal to 10 raised to minus 8 plus minus b square 10 raised to minus 16 minus 4 into 10 raised to minus 6 now. So basically you can ignore this 10 raised to minus 6. It's a very small number actually. But one more thing. Okay, just a sec. This is 10 raised to minus 6 now. Yeah, it will get added now. So this minus actually become plus. So basically this is 4 into 10 raised to minus 6 only divided by 2. By taking square root of it, what do we get? 10 raised to minus 8 plus minus 2 into 10 raised to minus 3 divided by 2. Again 10 raised to minus 3, this is 10 raised to minus 8. It's a very, very, very small number. Again, you can ignore it, no problem with that. So ultimately, you will get 2 into 10 raised to minus 3 divided by what? Divide by 2, right? So that will give you 1 into 10 raised to minus 3, right? So 1 into 10 raised to minus 3, that's your x now. That is your x. Now you want to add that x to this. So basically your H plus ion concentration is equal to 10 raised to minus 8 plus 1 into 10 raised to minus 3. Again 10 raised to minus 8 is a very, very small number. So 10 raised to minus 3, you can consider this as a H plus ion concentration. Okay. So now whenever you take the negative logarithm of this concentration, what do we get? Negative logarithm of H plus ion concentration, that gives you pH is equal to 3 minus log 1. 3 minus log 1. So 3, what is log 1? Log 1 is actually 0. So 3 minus 0, 0. So pH basically is equal to 3. So that is how you can find out the pH for such solution. That is way of calculating it. Okay. So moving ahead. Now that is for the pH calculation. We find out the pH calculation of different types of solution. Now taking that forward, firstly what we saw is the strong acid solution, right? Now we're gonna see the strong base solution. What will happen when you have a strong base solution? It is just like the H plus ion concentration of pH only. It is not something different. Okay, exactly same. Only thing is that in pH you have a H plus ion concentration. Here you have a OH minus ion concentration. Okay, so what do we need to do here is that calculate the OH minus ion concentration. Calculate the OH minus ion concentration, which will be equal to normality. Calculate the OH minus ion concentration, which will be equal to normality of a strong base solution. And then you can use the relation Kw is equal to H plus into 10 raised to, sorry, Kw is equal to H plus into OH minus is equal to 10 raised to minus 14. That will help us to calculate the H plus. Once you get the H plus, obviously what will happen? Once you get the H plus, you will surely get the pH. Once you get the pH, you can calculate the pOH also. Okay, hi Viravali, Bhaskar. Very good evening, beta. So yeah, now pH of 10 raised to minus 7 molar NaOH solution. Okay, now how can we do this now? Obviously, your NaOH will be put into the water. So you get Na plus, or let's write it in a different way as what we are concerned with OH minus only. We don't need to care about anything else here. So OH minus concentration is how much? 10 raised to minus 7, isn't it? Initially, it will be always be that much, right? 10 raised to minus 7 molar. But at equilibrium, what will happen? Now, one more thing you need to focus here is that OH minus ion concentration is also equal to 10 raised to minus 7. So, is it smaller than 10 raised to minus 6? Yes, it is smaller than 10 raised to minus 6. Remember the very first slide I told you here? It is smaller than 10 raised to minus 6. That means you need to consider the OH minus ion which came from water also. So at equilibrium, it will be 10 raised to minus 7 plus x. And this H plus ion will be also equal to x. Now, as we go in the earlier case, what do we do then? 10 raised to minus 7 plus x multiplied by x divided by what? Divided by the concentration of your NaOH, which was 10 raised to minus 7. This will be equal to what? 1 into 10 raised to minus 14 kW, isn't it? Just the way we solved it for the last numerical. Exactly same way. No difference. So then this will go up it will become plus, that will become 10 raised to minus 7 only. Now, what does it gives you? 10 raised to minus 7x plus x square. So that ultimately gives you x square plus 10 raised to minus 7x minus 10 raised to minus 7 is equal to 0, right? So this again comes into the form of what? Ax square plus bx minus c, right? Then how do we get the x? Your x will be equal to minus plus minus b square minus 4ac divided by 2a, right? What is your b? 10 raised to minus 7 minus 10 raised to minus 7 plus minus under root b square. What is b square again? 10 raised to minus 7 square, right? Minus 4a. What is a? Is 1 into c. What is c? Minus 10 raised to minus 7 bracket complete divide by 2a, which is 2, right? So now what does it give you? Your x will be equal to minus 10 raised to minus 7 plus minus under root. Now b square 10 raised to minus 7. Hi, Viravali, Bhaskar, Sikar. Hi, good evening. So 10 raised to minus 7, squaring it will become what? 10 raised to, well, you know what? 10 raised to minus 7, if you square it, it will become 10 raised to minus 14. But then again, you will take square root of it, right? So it will ultimately become 10 raised to minus 7 only. It will ultimately become 10 raised to minus 7 only. But anyways, let's write it first. 10 raised to minus what? 14 minus this will become plus now. Minus minus 1. 4 into 10 raised to minus 7 AC divided by 2a, which is your 2 only, right? So this will be equal to what now? It is something strange now. 10 raised to minus 7, 10 raised to minus 7. Let me figure out what to do here. B square 10 raised to minus 14 now minus AC 10 raised to minus 7 10 raised to minus 14 yes, Viravali, just a sec. I'm finding it out. Did you ask me anything? Why are you putting a question mark there? W, you got the OH minus and concentration. H plus OH minus, then is to minus 7 to minus 7. Okay, you're also on it. So yeah, 10 is to minus 7 plus minus 10 is to minus 14 plus 4 into 10 is to minus 7. We can actually consider this as actually we can ignore this. This will give you under root 40 10 raised to minus 8 divided by 2. So that will give you 10 minus 10 raised to minus 7 plus minus. If you take a square root of 40, it will be somewhere around 6 point something. So 6 10 raised to minus 8 will become 10 raised to minus 4 divided by 2. Again 10 raised to minus 7 is a very small quantity. We can ignore it. It will become 6 into 10 raised to minus 4, which ultimately equal to 3 into 10 raised to minus 4. So 3 into 10 raised to minus 4, if you add here, here also you can ignore 10 raised to minus 7. So you will get 3 into 10 raised to minus 4. Taking negative logarithm of this, it will give you 4 minus log 3. 4 minus log 3 equal to what? Log 3. Let me tell you the values of log. Log 1, 2, 3, 4, 5, 6, 7, 8. For log 1, it is 0. Log 2, 0.30. Log 3, 0.47. Log 4, 0.60. Log 5, it is 0.69. Then log 6, 0.77. 0.84, like that. Okay. But anyways, we need log 3 only. Log 3 is 0.47. So 4 minus 0.47, that is equal to 3.53. So 3.53 is your pOH. pOH is equal to 3.53. Then what is our pH? pH is equal to 14 minus 3.53. So 14 minus 3.53 is how much? 10.47. That is what the pH of this solution. It's very, very high. It's a highly basic solution. Okay, 10.47. That is how you can actually calculate this calculation to find out the pH and pOH. Okay, so the pH calculation from different types of solution is a very, very, very large segment. It's a very large segment, and we're gonna extend it. We're gonna extend this segment to the next lecture, where we're gonna see how there are some other ways to calculate the pH from different types of solution. Okay, so that's it for today's lecture, guys. Thank you very much. I hope you like this video. If you like this, please like the video, comment on it, subscribe to Practical Live on YouTube. If you have any doubt, you can post in the comment section. Secondly, you can also download our app from a Google Play Store, or also from an Apple Store. Okay, you can download from it. You can log into it. You can explore different courses. We have a courses in a Vedic maths, coding, chess, robotics. Recently, we started a course in a Python also. And our app has brought a very innovative thing in a hashtag, and that is scan anything. You can scan anything and you can obtain the information from that particular object. Okay, so that's it for today's lecture. Bye bye from my side.